Okay, Assalamualaikum and very good afternoon to everyone. So this is a lecture on design concept. So in this lesson, you should be able to explain what is software design and elaborate what are the guidelines for good design and to define the quality design, and also to discuss some fundamental design concepts and also to look into design model for interface. Okay? So first we're going to start with introduction to software design. So the author of Lotus presented a software design manifesto, and he said that a good software design should have this following criteria. Okay, the first one is firmness, that a program should not have any bugs that inhibit its function. That means there should be no error. Commodity, that is, a program should be suitable for purposes for which it was intended. That means it should do whatever it was planned to do. And delight in terms of the experience of the users who are using the system. So to him, these are the good criteria for software design. Okay? Software design comprises the set of principles, concepts, and practices that lead to the development of a high quality system. Okay, so with this set of rules, principles, and guidelines and concepts, so this can help the designer to make decisions as to what is the basis of their judgment in terms of choosing certain kinds of design. Okay, so design concept must be understood before the application of the concepts. So as a software designers, we have to have some level of understanding in terms of this design concept so that we can make the right decisions. Okay. So in this course, we're going to look at design from 4 perspectives, which are: the first one is from data or class design. The second one is in terms of architectural design. Third is in terms of interface design. And the last one is in terms of component level design. In terms of data or class design, these are the mapping from the previous stage, which is from the requirements or analysis stage into design stage. Okay. And in the architectural design, we further define the relationships between the components or the elements in the software solution. And the third one, we're going to look at how the software and the hardware and the user communicate. So this can also be seen from the interface design and also from the representation of the interface design. And finally, the component level design will transform the structural elements into software components. So in the analysis model, we have looked at the scenario-based elements such as use case specification, use case diagram, activity diagram, and also activity diagram with swim lanes. Okay, we also have looked into class-based elements such as class diagram. Okay, and in terms of behavior elements, we have been introduced to the state diagrams and sequence diagram. So other than that, for flow-oriented elements, we in the analysis model, we have data flow diagram and control flow diagrams, which are more related to structured approach. Okay, and also sometimes it can be also using narratives rather than using representation. Okay, so these all of these analysis model will be later on mapped to the design model. So this is what we're gonna look in this lesson. So in the 4 perspectives of the design model, it has mappings from one or more elements in the analysis model. Perhaps it is not one-to-one mapping. So if you are talking about interface design, it may come partly from the scenario-based element and may combine with behavioral element, combined with flow-oriented element in order to represent the interface design. So if you are talking about class diagram, yes, it has direct mapping from the analysis class diagram, which is further refined in the design model. Okay. So in the guidelines for good design, okay, so what are some of the guidelines for good design? Okay, the first one is the design must implement all of the explicit requirements and also implicit requirements from the stakeholders. So that means that if we have done the elicitation process and we have gathered the requirements or the needs from the stakeholders, we try as much as possible to include that in our design. Okay, remember that if we fail to include it anywhere in the design phase, that means it will not be designed and it will not be implemented, and in the end the needs of the stakeholders will be missing or incomplete. Okay. The second one is that the design must be understood by those who are going to read or interpret or refer to the design. For example, the programmer, they will refer to the design in order for them to do the implementation. Okay, and also perhaps the software tester, they may also need to refer to the design in order for them to do the testing. Okay, and the third one is that the design should provide a complete picture of the software, okay, addressing the data, the functional and the behavioral domains from an implementation perspective. Okay, so that means it will be much more refined and much more detailed that it will be used in the implementation later on. Okay. So now we move on to quality design. In quality design, we should have an architecture that has some of these properties. Okay, the first one is that it has been created using existing architectural styles of patterns. Okay, why? Because these styles and patterns, they have been used by other people and it has been proven that it has worked and it can solve the problem. Okay, so we will look into patterns and architectural styles towards the end of the video. Okay. Okay, the second one is to produce an architecture that follow the good design characteristics. Okay, so as a designer, you should know what is the reason that you choose certain kind of design. Okay, so that must be based on some principles, some concepts. Okay, and it can also be implemented in an evolutionary fashion, meaning that it can keep on evolving and keep on changing. Okay, so when we talk about design, normally the impact of design will be seen during maintenance. Okay, so if you have followed good recommended practices of design, then the impact of any maintenance activity will not be a severe one. Okay, and a design should also be modular. That means that you have grouped them or partitioned them into smaller elements, because as a human, it is not recommended to have one complex problem and you expect to solve everything. So it's better to have it in a smaller modular elements, then we can focus on each of the modules and try to solve the problem. And even if we have error, so we can just focus on that modules and fix the error. Okay, so this way we can say your design is of good quality when the maintenance can be done with less effort and less changes to the existing solution. Okay, a design should also contain distinct representations of data, architecture, interfaces, and components. That means that if you want to look at the data, you look at the representation for the data. Okay, for example, you look into the class diagram or the ERD diagram, okay, to just look into the data part. If you want to look at the architecture, you refer to the architecture diagram. If you want to look at the interface, you refer to the interface. Okay, a design should lead to data structures that are appropriate for the classes to be implemented and are drawn from recognizable data patterns. So these are coming from data structures. So you use proper data structures as you will learn in data structure courses. Okay, so we have for CS we have at least 2 data structure courses. So this represent the data part. Okay, so if let's say something is wrong with your data and you want to change your change of the data structures should only be applicable to the changes in the data structure. So that will mean that the way you design is good enough that it does not affect other parts. Okay, then the design should lead to components that exhibit independent functional characteristics. Okay, so when you design, each function should be highly cohesive. You will hear the term later on. Okay, a design should lead to interfaces that reduce the complexity of connections between components and with the external environment. So we want to have an interface that can help us to reduce the dependencies or connections. Okay, a design should be derived using repeatable method, okay, that is driven by information obtained during the earlier phase, which is the requirements analysis phase. Okay, and it should be represented using notation that is understandable by other team members. Okay, so that is why in software engineering it is important for us to use standard notations. Okay, now move on to design principles. As I said just now, there are a lot of actually design principles, because these principles, guidelines, they are from previous experiences of practitioners. Okay, so there will be endless principles. Okay, so let us just pick a few from this. Okay, so the design should be traceable to the analysis model. That means the previous model. Why? Because we need to make sure that everything has been included in the design. Okay, the design should not reinvent the wheel. That's why they recommend us to use the architectural styles, the design patterns, the data structures. These are all pre-existing design elements. Okay, so that we don't have to start from scratch, and this has been proven. Okay, and the design is not I'm just skipping some of this. Okay, the design is not coding, and coding is not design. That means that when you do design, there must be a process of it and the outcome of it. And when you do coding, you will be based on the design. Okay, so that you need that the design element to go further for the development. Okay, so for example, in your project, some students, they just do the implementation or the prototype. They screenshot the prototype. They say this is their design. Okay, so that is not design, that is the implementation part. So what is the design? When you before you come out with the implementation, you must have some series of activities in order for you to pick which one that you want to apply for your implementation. Okay, so that's why you need to come out with the design, the interface design that is on the interface part. Okay, design should be structured to degrade gently even when aberrant data, events or operating conditions are encountered. That means if there is any change, any error that you need to fix, then it should not give a big impact to the whole system. Okay, and this design, they should be reviewed and assessed, okay, from time to time. Okay, not necessarily towards the end then only you get an evaluation of it. Okay, because some of the experienced people, they can, based on their experience and their knowledge, they can look at the design and already give good feedback on whether there will be a problem or not with such a design. Okay, so as I said, the most significant impact of design is when you do maintenance. Okay, so I'm talking about apart from the user interface. Okay, because user interface, you can get feedback from the user satisfaction, right? When they use it, they can give feedback directly. But when you talk about the other parts, like the architecture, the component, the modules, okay, the impact of it can be seen when you do maintenance. Okay, so when you change certain things, what is the result of the change? Okay, is it going to be maximum or minimal? So if it is minimum effort, okay, that means that the design is of good quality, that is based on some guidelines. Okay, so that is why you can achieve that quality.